My name is Louise Daly, and in this presentation, I'll be exploring the role of explainable AI, or XAI, in cybersecurity. As cyber threats continue to evolve, government agencies like DARPA, the Department of Defense, and even the NSA are investing heavily in AI systems that can not only detect and respond to threats, but also explain their reasoning behind the actions they take. The stakes are high. National infrastructure, defense networks, and civilian systems all depend on cybersecurity models we can actually trust. That's where XAI comes into play. Over the next few minutes, I'll walk you through how explainability is being integrated into these systems. From the types of machine learning models that support it, to ways it's being applied, and how we design AI to make its decisions transparent and usable in high-risk environments. I've organized this presentation into three main areas. First, we'll be focusing on relevance, or why explainability is so important in cybersecurity decision-making. Second, we'll talk about applications, or what exactly XAI is being used for and the machine learning models that power it. And finally, we'll take a look at the architecture, or how XAI systems are actually built to deliver useful, human-centered explanations. These three areas, the why, what, and how, will guide the structure of our journey through XAI and cybersecurity. So let's start with why explainability even matters in cybersecurity. This image highlights the three big goals of cyber AI systems: automation, intelligence, and trust. And trust is the one that everything else depends on. Whether we're talking about protecting federal infrastructure or defending enterprise networks, the people using these systems need to know why an AI made the decision it did. Imagine a security analyst getting an alert that says, "Threat detected, take action." If there's no explanation behind that, they might hesitate. Or worse, they might ignore it. But if that same alert includes the reasoning, maybe something like unusual port scanning behavior matched known attack patterns, that gives the analyst the confidence they need to respond. Explainability doesn't slow things down, it supports better, faster decision-making by building trust in the system's intelligence. And this diagram is great because it makes the problem crystal clear. At the top, we've got a classic black box model. It spits out a decision, but gives no insight into how it got there. And on the bottom, we see what happens when you add explainability. The system still makes a decision, but it also gives context. Maybe it highlights a known threat pattern or unusual behavior that triggered the alert. That added layer of reasoning builds trust, and trust leads to confident action. Now that we understand why explainability matters, let's talk about the core technologies that power it and how they're being used in the field. This diagram highlights the major AI approaches driving cybersecurity today. We're talking about machine learning, deep learning, knowledge-based systems, and even large language models and multimodal intelligence models. These are already being applied in government cybersecurity efforts, from automated threat detection in federal networks to AI-driven risk scoring for classified systems and anomaly detection for zero-trust environments. They also play a role in intelligence fusion, where models pull together signals from all different domains, like network traffic, device behavior, and threat intelligence feeds, all to support national defense operations. But even with this power, these models need to be explainable. Decision makers, from cybersecurity analysts to defense personnel, have to understand what the system is seeing and why it's recommending action. Without that layer of transparency, you don't have intelligence. You just have automation you can't necessarily trust. Building on that last slide, let's break down the learning models that sit beneath these technologies. Supervised learning is widely used in national threat databases. It trains on labeled data to recognize known attacks. Think phishing detection, malware classification, or detecting insider threats based on behavior patterns. Unsupervised learning is essential for anomaly detection in classified networks, like flagging unusual activity that doesn't match any known signature. That's huge in identifying advanced persistent threats or zero-day exploits. And reinforcement learning is starting to show promise in cyber defense simulations, helping systems learn how to respond dynamically to evolving threats, something DARPA and other defense agencies are actively investing in. XAI comes into play by making these models more transparent. Whether it's through decision trees, rule lists, or SHAP values, the goal is to provide actionable insights, not just alerts. Especially in high-stakes government contexts, You need models that explain themselves just as well as they perform. Now that we've looked at where XAI is being applied and the models behind it, let's talk about how explainability is actually structured in cybersecurity systems, especially in the context of government operations. This taxonomy comes from the design of XIDS, or Explainable Intrusion Detection System, which are used to monitor and secure critical infrastructure, military networks, and other high-value targets. On the left, we see the black box models, powerful but opaque. They often require extra layers of explanations just to make sense of their outputs. But in most government settings, that level of opacity just isn't acceptable. There's too much at stake. That's why the focus often shifts to white box models, shown on the right, things like rule-based systems, clustering, or statistical methods. These approaches are transparent by design. They're easier to audit, easier to explain, and easier to defend in high-stakes environments where decisions might be reviewed by policymakers, legal teams, or oversight committees. So when we talk about operationalizing XAI in government cybersecurity, we're not just choosing a model, we're choosing how explainable, defensible, and actionable the system will be. Now, to close out our look at architecture, this diagram zooms in on a key principle. XAI only works when it's designed with the user in mind. In government cybersecurity systems, that might mean a threat analyst, a system administrator, or even a compliance officer. Each of these roles needs a different type of explanation. Some require detailed model-specific reasoning, others just need a clear, actionable summary. We also see that explanations can be local or global. Local explanations help clarify a single decision, like why a specific alert was triggered, while global explanations help teams understand how the system behaves overall. And then we've got evaluation metrics. These are the standard that tell us whether the explanations are actually useful. Is it human-grounded? Does it align with operational goals? Can it support decision-making in time-sensitive scenarios? In cyber national security environments, explainability isn't abstract, it's operational. The success of an XAI system depends on how well it communicates with the people who rely on it. So to wrap things up, this image gives a full spectrum view of how XAI is being used across cybersecurity operations, from predictive maintenance and anomaly detection to incident response, access control, and cyber awareness. What's clear here is that explainability isn't limited to one part of the process. It plays a role at every stage, from anticipating threats to responding to them, from assisting users to optimizing systems. In military and government systems especially, these use cases matter. You need models that can spot an intrusion and explain why it requires attention. You need automated responses that still give human users enough context to take action or override the system when needed. XAI is what makes that possible. It connects powerful AI technology with real-world operational needs, where clarity, accountability, and trust are the priority. So as cyber threats evolve and AI takes on more responsibility, XAI is the potential key to making sure those systems stay secure, transparent, and human-aligned. Thank you.